Welcome back, students. In the previous videos, we talked about trigonometric functions and their derivatives. First half, just elementary. Product rule and some trig functions. Quotient rule and some trig functions. A little bit less elementary. Product rule and quotient rule put together. Quotient rule first, and then this part was product rule. Next, we had chain rule as well as product or quotient rule. Quotient rule first and then chain rule, because this is composite and that too is composite. Next, very important types of problem. The outside function is third power function, not sine. Power function is the outer function. Next, let's do this, and let me see. Does everybody see that this outer structure is the product rule? We have the first function u, and then we have the second function v. So we're going to get u prime v plus uv prime. Okay, just a moment, please. No. Alright. And this part will become the product rule part. Here, we need the derivative of the original function. Okay. And then here, we need the derivative. Okay, that's the structure. U prime v plus uv prime. Next, let's fill out these dots. Again, I cannot emphasize the importance of this separation. You can do this all at the same time if you're really good at it. But even if you think you're really good at it, my suggestion is don't do it. Separate it in several pieces like this. Dot 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 is perfect, or you can use Leibniz notation of ddx or ddt if you prefer. In any case, I cannot emphasize this too much. It is very important to slow down to protect yourself. I can clearly see that when I grade. Students who try to slow down do a lot better, not just a little bit, but a lot better than the other students. Okay, let's got this. We got this. Let's take the derivative of the first function, the derivative of this tangent part. It's a chain rule, and we take the derivative of the outer function. What's the derivative of tangent? We have secant squared. Nothing changes inside. And times, we have to multiply the derivative of the inside. What's the derivative of the inside? 2t, no, excuse me, 6t plus 2. I think that's it. Let's color code this one as blue function. This part is blue. And then, okay, this part is blue. What did he use? The chain rule. Derivative of tangent is secant squared. Nothing changes inside. And finally, we multiply the derivative of the inside. The chain rule is done, and that is the derivative of the first function in this product rule problem. Okay, let's take care of the second derivative here, or the derivative of the second factor. Let's copy this. What is the derivative of a logarithmic function? The derivative of log is 1 over x. So what you multiply here is 1 over whatever that was the inside. T squared plus cosine squared of t. Alright, and then we multiply the derivative of the inside. Let's see, what's the derivative of the inside? What's the derivative of t squared? 2t, that was easy. Next, what's the derivative of cosine squared? That's a bit more challenging, because what's the outer function in this case? Is cosine? No, the outer function here in this case is second power function. So taking the derivative, power comes out as coefficient, inside stays the same, and then what do? We multiply the derivative of the inside, the derivative of cosine. This whole part is red, the derivative of the second factor. Among them, pay particular attention to this part, cosine squared part. Derivative of this. Outer function is square, so 2 comes out, we get 1 power, so you don't have to write it. So we get 2 cosine of t, and then the inside, derivative of inside, what do you get? We get negative sine, and this part comes from the derivative of cosine squared. This overall is red part, the second function, but among this cosine squared, that deserves special attention because outside function is a power function, not trigonometric function. This cosine squared is actually shorthand of cosine of t squared, and the outer function is clearly the second power function, and then inside is cosine function. Why are we using this abbreviated notation, cosine squared or sine squared or secant squared or whatever? It's just by tradition. You just have to get used to it. Personally, I'd prefer to uninvent this, but it's too late.